Lesson 5-8, Rational Zero Theorem. So by the time we're done with this lesson, we should be able to identify possible rational zeros of a polynomial, find all the rational zeros of a polynomial. So to start with, the rational zero theorem determines the possible rational zeros of an equation in the form of P over Q. So really what we're doing with this is we're actually, if we think back to what we've been doing, we are finding the factors of a polynomial so that we can solve them. Okay? So the rational zero theorems helps us to find those factors. And this P over Q means that we are going to take the factors of the constant. So factors of constant. So that's the number without a variable. And then the Q are the factors of the leading coefficient. So LC stands for leading coefficient. Okay? So we're going to list all the possible rational zeros, and then depending on what the directions tell us, we will find any of the actual rational zeros using synthetic substitution or graphing. So if we're graphing, we're looking for the places where it's crossing the x-axis. So we want our remainder, for using synthetic substitution, to be 0. Okay. So to start with, we're just going to go through and figure out how to make our list of possibilities. So whenever we do this, we always start by finding the factors of the constant. So that's the number without the variable. So this is our constant. So all the numbers that multiply to be 16 are 1 and 16. Or I could take negative 1 times negative 16. So we're going to put a plus and minus in front of all of these numbers. Let's see, 2 times 8 also is 16. See, 3 doesn't go in there. And then 4 times 4. So we don't need to list the 4 twice. And then we are going to have our factors of the leading coefficient. So that's number in front of the highest power. So 4 is our leading coefficient. So all the numbers that multiply to be 4 is 1 times 4. And then we will also have 2 times itself. Okay. So from there, we are going to make our list of possible rational zeros. Okay, so this line is going to be our answer. So we're just setting up a fraction. So we're taking each number in the constant divided by each number in the leading coefficient. So 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. And then we go back and divide 2 by all of them. So, or by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1, which is already on the list, so we don't need to rewrite it. 4 divided by 2 is 2, again on our list. And oh wait, I forgot my 8 and 16. So let's see, let's go back and divide those by 1. So we would also have 8, so 8 divided by 1, and 16 divided by 1. Okay. And then if we divide 8 by 2, that's 4, which is already in the list, and 16 divided by 2 is 8, which again is on our list. And then now we're going to go back and divide everything by 4. So 1 divided by 4 is 1/4. And then 2 divided by 4 would simplify to be 1/2, which is already on the list. 4 divided by 4 is 1. 8 divided by 4 is 2, so again that's on our list. And 16 divided by 4 is 4. So this would be our answer to this question. So we only are making our list at this point, so we're not solving the problem. Alright, so if we do one more example like that, again we need the factors of the constant. So in this case it's going to be 24. So 1 divides into 24, 2, 3 divides into 24, 4 divides into 24, 6 divides into 24, 7 doesn't, 8 divides into 24, 9 does not divide into it, 10 does not divide into it, 11 does not divide into it, and then 12 does, and it will be 24 as the last one. And then our leading coefficient this time is 1. So the only numbers that multiply to be 1 are just 1 times itself. Okay. So now we're going to take each of these numbers and divide it by 1. So if I'm just dividing each of them by 1, it's not going to change anything. So our list is going to be 1, 2, 3, 4, 6, 8, 12, and 24. And again, we need that plus minus in there because we can take two negatives times each other to get a positive answer. Okay? So again, this is just how we come up with the list.